So I'd like you to have a look at this question, perhaps have a go before we go through it. Pause if you need time to have a go at this question. Now, before we start this question, I'd like to remind you of the change of basis formula. Very straightforward. Log of base A of B. If you want to change it to another base, say C. B is on top, so it's the top part of my fraction. A is on the bottom, so it's the bottom part of my fraction. Okay, that is just a simple way to memorize that formula. So just please take a note, a mental note if you like. We will be using this formula. So here we can see that we have a slight problem with this question. That's a log with base 9. That's a log with base 3. So the first obvious thing to do is to change the base. Now, the trick is change it in terms of the smaller base. So the smaller base is 3. Okay. So on the right hand side, using my change of base formula. Okay, so it's going to be, now I'm going to change the base I'm changing to, is going to be 3. So log with base 3 of the top part, 6x squared minus 19x plus 2, all over log with base 3 of the bottom part, 9. Just using the change of basis formula. Now, many times I've emphasized this point. This part of my fraction, if you are stuck, you can press it on a calculator. However, you should recognize just from the definition of a log, so I'm going to slow this right down, what that is equal to. Log with base 3 of 9. If we don't know, I'm going to call it the number x. And just from the definition of a log, that means that 9 has to equal to 3 to the power of x. Okay? Many times. And here, 3 to the power of 2 is equal to 9. Therefore, x has to equal to 2. So this whole expression is simply another way of writing the number 2. So let me just, I won't be lazy, I'll write it out again. So log with base 3 of 2 minus 3x has to equal to log with base 3 of 6x squared minus 19x plus 2 all over, and I've explained that this number is simply the number 2. Next thing I do is to get rid of the fraction on the right hand side. So I can multiply both sides by 2. And I'm left with 2 Now, the next step, I'm almost ready to get rid of the logs apart from this 2 at the front. Okay? And I can use the power law, which is that the 2 in the front can go up. Okay? So if I did that, on the left hand side, I'll be left with log of base 3 of 2 minus 3x squared, the power law. That has to equal to log base 3 of 6x squared minus 9x plus 2. Now, I've got log with the same base on both sides. That means that this has to equal to this. So now I can solve, and this is 19x. It's a deliberate error. So now I've got the same base on both sides. So I can now equate the two expressions inside and say that 2 minus 3x squared is equal to 6x squared minus 19x plus 2. I'm not going to waste too much time showing you how to expand brackets. We should be able to do it very quickly. So it's going to be 4 minus 12x plus 9x squared is equal to 6x squared minus 19x plus 2. I take everything to the left hand side to make the coefficient of x positive. I have 3x squared plus 30 plus 17x. Is that right? 7x plus 7x. And I have here plus 2. To the left hand side. I believe that is correct. Thank you very much. And here I can see a straightforward factorization. 3x so x is equal to minus a third, or x is equal to minus 2. Now I have to be slightly careful here, because what happens when I sub in x is equal to minus a third into here on the left hand side? Let's just do it. 2 minus 3 lots of minus a third is 3. That's a positive number. I can't have log of a negative number, so I have to be quite careful. Here, what happens if x is minus a third? Let's substitute x is equal to minus a third into there. And when you do that, in both cases, you're going to have positive values on both sides for both x equals to minus a third and x equals to minus 2. So it's okay, but you always have to check back into your algebraic expression whether you end up with a log of a negative number, which you can't have. Okay, so you have to discount that solution.